Section 9.1, Similar Right Triangles. By the end of this lesson, you should be able to solve problems involving similar right triangles, and you should also be able to use geometric means to solve problems. So we're going to start with our first theorem of Chapter 9. And the theorem says, if the altitude is drawn to the hypotenuse of a right angle, then the two triangles formed are similar to the original right triangle and to each other. So taking a look at this and really examining what this means, we have an altitude here. And the altitude is drawn to the hypotenuse. We know that it's an altitude because it's perpendicular to the hypotenuse. And there's two triangles that form. There's one over here, ABC, and I'm going to outline that in blue. And we have our other triangle, ACD. And these triangles are going to be similar to one another, and they're also going to be similar to the large triangle, ABD. Taking a look at this, it might help to redraw these triangles as three separate ones. So here we have triangle CBA. Here we have triangle CAD, which is this one, and BAD is the large triangle overall. Now, when we start comparing them, it's going to be good that we can reference certain sides the same way. So we will always reference them as you have your hypotenuse, which is always going to be across from the right angle. You have your short leg, and then you have a long leg. And here all three triangles are drawn so that the hypotenuse, the short leg, and the long leg are all in the same position. Now, if these triangles are all similar, then that means that their sides are proportional. And the corresponding sides that are going to be proportional are going to be those that are listed here. So let's see this as an example. Here we have a problem that asks us to solve for AD. So we can put x in place of it. That's what we're trying to find. Now, when you're trying to set up a proportion, you're going to want to take a look and see what pieces you're given of these triangles. So if I redraw this triangle here, CBD, I see that I have this length here, which is 18, and this length here, which is 24. Now looking at this, I know that my hypotenuse is always going to be across from the right angle. This appears to be my short leg, and then 24 appears to be my long leg. And we know this too because of the measures that are given. Now if we recreate the other triangle that I'm given a measure for, and I'm looking to find, I'm going to use ADC. So ADC. CD is 24, and I'm looking to find what AD is. And looking at which sides are given to us, the hypotenuse is unknown, but it doesn't seem that we need it. This is our short leg, and here is our long leg. And what we can do next is set up a proportion. So I know that I'm given my long leg, and I'm looking to find my long leg. So that's one measure that we're going to want to use in our proportion. We also have measures for both of our short legs. So we're going to want to use that in our proportion as well. And when we set up our proportion using the lengths that we're given, we have 24 over x is equal to 18 over 24. And then from here, it's just like we'd solve any other proportion. You cross multiply in order to solve. So I'll get 18x is equal to 576. And in dividing both sides by 18, we find that x is equal to 32. And don't worry if this doesn't seem like something that's naturally easy to you. It does take some time getting used to figuring out what sides correspond with one another, which one would be the long leg, the short leg, and hypotenuse, and figuring out what triangles you're going to use. But that's what we're going to spend the next couple days in class practicing. Here's another example. So Ricky is riding a motorcycle off of a ramp. The ramp has a cross section that is a right angle. which would be this here. The diagram shows the approximate dimensions of this cross section. Find the height of the ramp. So here we're looking to find the height of this ramp, and we're given a whole bunch of different dimensions. What I will notice right away is that for my large right triangle, I'm given all 3 dimensions, which helps us when we're trying to set this up. What I might also notice is that if I'm trying to find the height, I am going to have to use a triangle that has this piece as part of it. So what I'm going to do is I will use this triangle, and for that triangle I know that I have h over 4.7, and if I take a look at what I'm given in this triangle, h is going to be my long leg, so you can write that next to it to help you set up your proportion, and 4.7 is the hypotenuse. So what I'm going to be looking for in my other triangles is another long leg and another hypotenuse. What I notice is that in this large triangle, I'm given my long leg as well as my hypotenuse. So that's the other triangle that I'm going to use when I set up this proportion. So the long leg for the large green triangle is 11, and the hypotenuse is 11.7. Once we have our proportion, we can just cross multiply to solve. So I have 11.7h is equal to 51.7. And then we're going to divide both sides by 11.7 in order to solve for h. And we find out that h is going to be about 4.42 feet, since we're working with feet here. Now there are 2 other theorems that are mentioned in your textbook, and this theorem says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of the altitude is the geometric mean of the length of the 2 segments. So looking at this, we can highlight some pieces of information. I have BD, which is here, and then I have CD, which notice that this is the piece that they're mentioning that's dividing this up. And we also have AD. So anytime you are given these 3 lengths and needing to solve for one of them, you can use the geometric mean for it. Our other theorem says that in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into 2 segments, which we see right here. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So we have AB, which is this whole entire segment that we see in both of these. CB, which is this segment. We also have DB. So looking at this first one, we see that we can set up a proportion using these pieces here. For the next one then, we would take a look at it in a different way. AB is still our hypotenuse. Instead, this time we are going to be using the longer leg, AC, and AD. So once again, these theorems you could memorize if you wanted to. However, you will always be able to solve these right triangles if you match up corresponding sides. So knowing, if you have a short leg, a long leg, or a hypotenuse that's given, and setting up a proportion accordingly. All right, that's it. So just the reminder once again that you can use the theorems, but when in doubt, just look for corresponding parts. And it's time for a joke. How do you catch a squirrel? Well, you can climb a squirrel, or sorry, you can catch a squirrel by climbing in a tree and acting like a nut.